Picture this. It's 1985. You want to fly from Los Angeles to Sydney. You'll need to stop in Honolulu. Maybe Hawaii, definitely refuel. Now imagine boarding a plane that says, "We're skipping all that," and flies 8,000 miles nonstop on just TWO engines. Impossible? That's exactly what airlines said. Until Boeing built a plane so revolutionary, it didn't just change aviation. It rewrote the physics of how we connect the world. What's up, aviation enthusiasts? Today, we're diving deep into one of the most significant aircraft ever built, the Boeing 777. This isn't just another plane documentary. This is the story of how engineers, pilots, and visionaries came together to create something airlines insisted was impossible. A twin-engine aircraft that could fly further than four-engine giants, carry more passengers than most wide-bodies, and do it all while burning less fuel. Stick around, because by the end of this video, you'll understand why the 777 is called the most successful wide-body jet of all time. The problem airlines faced. Let's rewind to the late 1980s. Airlines had a problem, and it was expensive. International travel was exploding, but their options were limited and frustrating. If you wanted range, you bought a Boeing 747 with 4 engines. Incredible aircraft, but it seated 400+ passengers. What if your route only needed 300 seats? You were burning fuel on empty seats, losing money on every flight. The alternative? The Boeing 767 or Airbus A300, great planes, efficient twin engines, but they couldn't fly far enough for true long-haul routes. Airlines were stuck playing a game of compromise, and nobody was winning. The bold request then, in 1986, major airlines, led by United Airlines, walked into Boeing's offices with an audacious request. They wanted a plane that could seat 300 to 400 passengers, fly 7,000 to 8,000 nautical miles nonstop, and do it all on just 2 engines. Boeing's engineers looked at each other. The laws of physics hadn't changed. Twin-engine aircraft had range limitations. There were regulations, called ETOPS, Extended Range Twin-Engine Operational Performance Standards, that restricted how far twin-engine planes could fly from the nearest airport. For safety reasons, you couldn't just strap bigger engines on and call it a day. But here's where Boeing made a decision that would change everything. Instead of telling airlines what they could build, they asked airlines what they needed. This became the first commercial aircraft designed entirely through digital computer-aided design, and more importantly, through direct collaboration with the 8 major airlines that would fly it. The TOPS revolution now. Let's talk about ETOPS, because this is crucial to understanding why the 777 was so revolutionary. Before the 1980s, aviation regulations were paranoid about twin-engine planes over water. The thinking was simple. If one engine fails, you have one engine left. If that fails, you're swimming. 4-engine planes like the 747 had redundancy. Lose one engine, you have 3 more, lose 2, still flying on 2. This made regulators comfortable with transoceanic routes. But engine technology had evolved dramatically. Modern turbofan engines were incredibly reliable. Airlines and Boeing knew this. The challenge was convincing regulators. Throughout the late 1980s and early 1990s, Boeing worked with aviation authorities to expand ETOPS certification. They proved that modern twin-engine aircraft could be just as safe, if not safer, than older 4-engine designs. This regulatory shift opened the door. Now, Boeing just had to build a plane that could capitalize on it. Digital revolution, the 777 became the first commercial airliner designed entirely on computer. Every single part, all 3 million of them, existed digitally before a single piece of metal was cut. Boeing used CATIA, a French CAD software, to create a complete digital airplane. Why does this matter? Because in traditional aircraft design, engineers would create parts, build them, then discover they didn't fit together properly. Millions of dollars wasted. Months of delays. The 777's digital design meant every component was tested for fit virtually. When parts arrived at the factory, they fit together perfectly on the first try. This wasn't just efficient, it was revolutionary. The engine decision, but the real magic was in the engines. Boeing offered the 777 with 3 engine options: Pratt & Whitney PW400, Rolls-Royce Trent 800, and General Electric GE90. These weren't just big engines. They were the most powerful commercial turbofan engines ever created. Let's focus on the GE90 because it tells the whole story. The GE90115B produces 115,000 pounds of thrust. To put that in perspective, that's more thrust than 2 Boeing 737s at full takeoff power. Each engine. The fan diameter is 128 inches, so wide you could fit the entire fuselage of a Boeing 737 inside it. This massive power solved the range equation. More thrust meant the 777 could carry more fuel, more passengers, and fly further than any twin-engine aircraft in history. The wing design, then there's the wing. The 777's wing is a masterpiece of aerodynamic engineering. With a wingspan of nearly 200 feet on the 777-200R variant, these wings are enormous. But size isn't what makes them special. Boeing designed the 777's wing with a supercritical airfoil, which delays the formation of shock waves at high speeds. This reduces drag and improves fuel efficiency. The wings also feature raked wingtips, those elegant curved tips you see on modern Boeings. These reduce vortex drag by up to 5%, which translates to hundreds of thousands of dollars in fuel savings annually per aircraft. The wing's flexibility is equally impressive. During testing, Boeing bent the wings upward to 24 feet before they finally broke at 154% of design limit load. This wasn't just meeting safety standards, it was obliterating them. Fly-by-wire technology, the 777 was also Boeing's first fly-by-wire aircraft. Instead of mechanical cables connecting the pilot's controls to the flight surfaces, the 777 uses electronic signals processed by computers. Pilots were skeptical. Boeing's reputation was built on giving pilots direct mechanical control. But Boeing's implementation was brilliant. They gave pilots the feel of mechanical controls while adding computer protections that prevented dangerous maneuvers. The aircraft couldn't exceed its structural limits even if pilots tried. This system also saved weight. Thousands of pounds of mechanical cables and hydraulic systems were replaced with wires and computers. That weight savings translated directly into range and payload capacity. Testing and certification before the first 777 could carry passengers, it had to prove itself. Boeing conducted the most rigorous testing program in aviation history. The first 777 flew on June 12, 1994, and over the next year, Boeing's test fleet accumulated thousands of flight hours. They tested everything. Engine failures at the worst possible moments. Extreme weather conditions. Maximum weight takeoffs and landings, emergency descents. The 777 passed every test, often exceeding expectations. The ETOPS certification was the final hurdle. Boeing achieved 180-minute ETOPS certification right at entry into service, an aviation first. This meant the 777 could fly routes up to 180 minutes from the nearest airport, opening up previously impossible routes. Entry into service on June 7, 1995, United Airlines operated the first commercial 777 flight from London Heathrow to Washington Dulles. It was a symbolic moment. This was the plane airlines had dreamed about, finally in service. But the real revolution happened quietly, route by route. Airlines started drawing lines on maps that had never existed before. Los Angeles to Melbourne, New York to Singapore, Dubai to Los Angeles. Point-to-point routes that bypassed traditional hubs. The hub-and-spoke killer for decades, international aviation operated on a hub-and-spoke model. You'd fly from your city to a major hub, then connect to your final destination. It was inefficient but necessary because aircraft couldn't fly long distances with economical passenger loads. The 777 changed this overnight. Airlines could now operate direct flights on routes that previously required connections. Passengers loved it. No connections meant no missed flights, no lost luggage, faster travel times. Airlines loved it because direct flights commanded premium fares. Cities that weren't major hubs suddenly had direct international service. The 777 democratized long-haul aviation. The variants that changed everything. Boeing didn't stop with one 777, they created a family of aircraft, each optimized for different missions. The 777-200ER became the workhorse of long-haul fleets worldwide. The 777-300ER extended the fuselage, creating essentially a twin-engine 747 with nearly the same passenger capacity, but dramatically better economics. Emirates alone has ordered over 200 777-300ERs, building their entire global network around this one aircraft type. Then came the 777-200LR, the worldliner. This variant could fly 8,555 nautical miles, making it the longest-range commercial aircraft ever built at the time. It could connect literally any two cities on Earth, flying over the poles if needed. It's the plane that made routes like Newark to Singapore possible, a flight that covers 9,000 miles in about 18 hours. Economic impact. Let's talk numbers, because this is where the 777's impact becomes crystal clear. Compared to a four-engine 747 on the same route, the 777 burns about 20% less fuel per seat. Over a year of operations, that's millions of dollars per aircraft in fuel savings alone. The 777 also has lower maintenance costs. Two engines instead of four means half the engine maintenance. Simpler systems mean fewer parts to fail. The digital design meant parts fit better, lasted longer, and were easier to replace. Airlines could operate the 777 with the same crew size as smaller aircraft but carry significantly more passengers. The economics were so compelling that the 777 became the fastest-selling wide-body aircraft in history. The environmental angle. In an era of increasing environmental consciousness, the 777's efficiency became a marketing advantage. Yes, it's still a large aircraft burning significant fuel, but per passenger mile, it's one of the most efficient long-haul aircraft ever built. The newest 777X variants take this further with composite wings, new GE9X engines, and advanced aerodynamics that promise another 10% improvement in fuel efficiency. In aviation, where margins are razor-thin, 10% is revolutionary. By the numbers as of 2024, Boeing has delivered over 1,777 aircraft to airlines worldwide. It operates on every continent except Antarctica. The 777 has carried over 3 billion passengers and flown over 5 billion nautical miles collectively. That's the equivalent of flying to the sun and back multiple times. It's the backbone of major airlines like Emirates, United, American, British Airways, and Singapore Airlines. Some airlines have built their entire long-haul strategy around the 777's capabilities. The 777X evolution continues. The story doesn't end with the classic 777. Boeing is currently developing the 77X family, featuring the 777-8 and 777-9. These aircraft feature folding wingtips to fit into the same airport gates as current 777s, despite having wingspans of over 235 feet. The GE9X engines powering the 77X are the most powerful commercial engines ever built, producing 134,300 pounds of thrust. They're so efficient they could change long-haul economics again, just as the original 777 did 30 years ago. Competition and market position, of course, the 777 hasn't operated in a vacuum. Airbus responded with the A350, an excellent aircraft that competes directly with the 777. The A350 uses even more composite materials and offers similar range and efficiency. But here's the thing. Competition validates the 777's original concept. Before the 777, airlines weren't sure they wanted large twin-engine long-haul aircraft. Now it's the only thing they buy. Four-engine aircraft are retiring rapidly. The 747 production has ended. The A380 production has ended. The future of long-haul aviation is efficient twin-engine aircraft, and the 777 proved it was possible. The human story behind every 777 are thousands of engineers, technicians, pilots, and airline employees who believed in an idea that seemed impossible. They worked together, solved problems nobody had solved before, and created something that changed how the world connects. The 777 is a reminder that aviation progress isn't just about technology. It's about vision, collaboration, and the willingness to challenge conventional wisdom. Airlines said they needed something that didn't exist. Boeing said, let's build it together, and they did. So there you have it, the story of how two engines rewrote long-haul aviation. The Boeing 777 didn't just fill a gap in the market. It created entirely new possibilities for how we connect cities, countries, and continents. It proved that sometimes the impossible just means nobody's figured it out yet. Next time you're boarding a long-haul flight, there's a good chance you'll be on a 777. Take a moment to appreciate what you're sitting in. It's not just a plane. It's the culmination of decades of engineering innovation, regulatory evolution, and collaborative design that changed aviation forever. If you enjoyed this deep dive into aviation history, hit that like button and subscribe for more content exploring the aircraft and technology that shape our world. Drop a comment and let me know, what aircraft should we explore next? The A380's rise and fall? The 787 Dreamliner's revolutionary technology? You tell me. Until next time, keep looking up, and remember, the sky isn't the limit when there are footprints on the moon and 777s connecting the world.